Hello everyone. Today I will be demonstrating the concept of this lab 9 related to interrupts, which focuses on the implementation of external interrupts on the ATmega 2560 microcontroller. So for this, we will discuss the lab task number 2, which says that we have to design a system such that for each external interrupts, so we will apply it for the external interrupts here generated. It displays on LCD which interrupt is generated, all three interrupts. So here we will simply use the push buttons and an LCD which will display the all three interrupts. Like for example, I press the first button, it says that IN20 interrupt is basically active. When I press the second button, it will say that int1 is now active, and when I will press the third button, it should say that interrupt number 3 is active. Okay, so now I will be moving on to the Proteus simulation for this. So for that, we will simply open our Proteus software. So, okay, let's move on to Proteus. So Proteus 8, let's start the simulation. So here we will go to the new project, and in the new project I will be using the predefined development board, and I will use here the ATmega 2560 board. Here is ATmega 2560 board. And now I will just rename it with my own credentials. So let's rename it. So now I have mentioned my name and ID, and I will also mention lab 9 interrupts. Okay, let's hit next. Next. So yes, this is our development board, the ATmega 2560. Now what I will do first is I will add an LCD here. For that I will type in LM106L. So I think I just wrote it wrong. It is LM016L. Yes, it is LM016L. So LM016L. Here is the LED. So just place the LED somewhere around here. Let's place it over here. Okay, so this is my LED. Now I will simply place some push buttons. So for that, just open the component menu and type in push button. So this is the button which we will use. It is a default button. So okay, let's just place it over here somewhere. I will place it over let's place it over here. And since we will use three interrupts, so I will place here three push buttons. So one, two, and here I will place three buttons. Okay, now let's just talk about the connection. So first I will just wire my buttons to the ATmega 2560 board. So for that I will wire my first button with PD0. So this is my first button, and I will simply connect it with PD0. So here is PD0. Okay, PD0. So let's just wire it with it. This is our first terminal. So I have just connected it with PD0 like this. Okay, PD0. Now what will I do is I will connect my second button with PD1. So let's move on to PD1. So here is PD1. This is our terminal. So let's connect it with PD1. So yeah, here I have connected PD1, and the last button should be connected to PD2. So let's connect it with PD2. Here is our PD2. Okay, so let's connect it. Okay, so this is our PD2. Here I have connected it with PD2. So let's check it again. So first with PD1, second with sorry PD0, second with PD1, and the third with PD2. Okay, now for these terminals, we will just place common ground over here. So let's place a common ground. So our ground is, where is our ground? Okay, here is our ground. So let's place it somewhere here. Now let's connect this terminal and just ground it. Now just ground this terminal also and ground this terminal as well. Okay, so the connection to the buttons is now successful. Now let's connect the LCD. So for LCD, I will simple use port A, like from here D0 to D7. I will go from port A, which is IO22 to IO29. So let's place default. Wait, here is default. I just selected the wrong option. So here is default. Okay, let's use the default pin. So let's place it here. One, two, three, 4, 5, 6, 7, and 8. Okay, so 7 and 8. Now let's make these connections. So for that, I will just go from IO22 to IO29. So let's start IO22 to IO29. So IO22, IO23, and here I will go with IO24. Here I will go with IO25. Here I will go with IO26. IO26. Now here IO27. IO27, 26, 24, 25, 26, 27. Here IO28. IO28. And the last one, which is IO29. IO29. Okay. Now, now we will simply connect our RS with IO37. So here is RS and I will just connect it with IO37. So IO37 is our PC0. So let's connect it with PC0. IO37. IO37. And then I will just connect my enable pin with IO36. So let's connect it with IO36. Here is IO36. IO36. And this RW pin, I will simply just ground it. So let's take it from here, and I should attach it with the ground. Now, okay, so now it's grounded, and I think that our connections are now perfect. So now we should move towards the Atmel Studio coding. Okay, so I'll just minimize it. Okay, let's just minimize it, and let me check my recordings where it's proceeding. Let's open our microchip studio. Okay, now it has opened. So let's start a new project. I will code in C, so I will select C, and here I will give my credentials, my roll number, and my name, lab 9 interrupts. Okay, lab 9 interrupts. So let's just go hit OK. Here I will type ATmega 2560. So this is ATmega 2560. It's loading. Okay, now I will simply, first of all, Since we are using an LED, so I will uh, head to the solution explorer, and here I will simply add my uh, lcd.h file. So here I will select existing item, and I think so I have saved it in documents. So let's head to the documents, Atmel Studio, and somewhere around, oh yes, here it is, our LCD predefined libraries. So now it is added. Now what we will do is we will paste our code. So I have already saved the code in here. So let's copy the code, copy, and let's just paste it over here. Okay, so now the code is here. Now I will just try to explain the code in very easy words. Not the whole code, but the main things which are important and which should be explained here. So let's move on to the code, and most importantly, I will basically explain the registers here. So let's head to it. So an interrupt is basically an automatic transfer of software execution in response to an hardware trigger. So to make this work, I basically configured two key registers. So let us find here the registers that we have used. So this is our interrupt service routines ISRs. But first of all, I will head to the registers. So I think so. Okay. So this is the initialization of the ports. Port A as the output LCD data and port C as the output. Now here we have initialized the LCD, and this is our triggering register, which is EICRA register. Now this is basically an external interrupt control register A. Here what I have done is I have set the bits for 10 for each channel. Now this configures the interrupts to trigger on a falling edge. Now what does it means that it means that the interrupts occur exactly when the button is pressed and the signal drops from plus 5 volts to 0 volts. So I hope you understand it. Now let's move on to the EIMSK registers, which is the enable external interrupts. So external interrupt mask register. Now what I have done here, so I have basically unmasked. I have unmasked or enabled I int 0, int 1, and interrupt 2 here. So the CPU knows to listen to these specific things. So basically, I have just enabled the CPU to recognize the interrupt 0, interrupt 1, and interrupt 2. Finally, I have used the SEI instruction enables, which enables the global interrupt flag. Now this is our global interrupt plan. This is the instruction that I used. So this acts as the master switch for all the interrupts. Now let's move on to the ISR function. So the code is basically not that long. It's a very simple code. So now I will explain the second concept, which is okay. So ISRs, interrupt service routines ISRs. Now what they do is they basically, when a trigger occurs, the controller jumps from the main loop to these interrupt services ISRs. So in my code, each ISR basically clears the display, okay, and it basically clears the LCD and displays exactly which interrupt was generated before returning to the main program. So we use the interrupt service routine ISRs. So basically when we press a button, once it says that now you have basically pressed the first button, which is directly linked to our interrupt 0. And when you suddenly press the second button, so it will directly say int 1, and then when you press the third button, it will say int is basically interrupt number 3. So yes, now how these things basically transform from int 0 to int 3 directly on your button press, this is because of the interrupt service routines ISRs. So I think I have just explained quite a lot. So now let's build this code. Okay, so build the solution. Let's debug it. So start debugging, continue simulation, and let's debug. Okay, so now I will press F11, 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 F11. Okay. Now the code is ready. So now what we will do is we will head over to the Proteus. So in here, I will just plug in the code. Let's head to our main file, documents, and in here, where is Atmel Studio? Wait, I can't. Okay, here is Atmel Studio, and here the lab is which lab? It is lab number 8. Sorry, lab number 9. Interrupts. So where is lab number 9? So lab number 9, lab number 9, lab number 9 is okay. Here is lab number 9. Interrupts. So now I will just paste the hex file. I will select the .hex hex file over here. Okay. So now let's just demonstrate the code. So now let's run the simulation. So first I have pressed the run button. So okay, so now it says that the system is ready to respond. So now when I hit the first button, let's hit the first button. This is my first button. Let's hit it. It says that interrupt 0 is generated. Now let's press the second button, which will trigger int 1. So let's hit over here. So yeah, it says that interrupt 1 is generated now, and the third should says that interrupt 2 is generated. Now where is our third button? Here is our third. Now I press it and it says that interrupt 2 is generated. So as you can see, the system responds instantly to the hardware events, fulfilling the task requirements. So I hope that I have performed everything, and now that this concludes my demonstration. The system has successfully detected and displayed all three external interrupts as it was required in the task. We have clearly shown all three external interrupts on our LCD. And most importantly, I have also mentioned my name, IDs in the file here also, and in the Atmel Studio code also. So I hope you like the demonstration. I actually performed every step very slow so that everything could be understood very easily. So thank you very much for the demonstration. See you soon.